You see, when things get too small, it's not readable in a video, right? This is the FemMobile 2, and this is the heart of the FemMobile 2. Two pairs of magnetic amplification generators that are shiftable in and out of engagement for producing power to the two magnetic drives in the rear wheel of 1500 or 2000 watts. That'll take you to 90 kilometers per hour. Just as the heart in the human body cannot perform its function of keeping us alive and metabolizing without other organs, like the lungs and the kidneys and the smaller ones too, so the heart of this is not like an engine that can be pulled in and pulled out. It's like an operating system that is contributed to by other elements that make the thing go fuellessly without batteries. The first induction one is the air turbine in the front. Here's an end view of the air turbine showing the turbine blades, showing the venturi tube that help compress the air so that at 10 or 15 miles per hour this thing begins to spin at 100, 200 revs, and it'll go up all the way to 800 or 1,000 at 60 or 70 miles per hour. But when this is lowered, the generator itself within this, these yellow circles, it doesn't make any energy. When this lever is pressed down, the base goes up and it goes from 3 inches to 1/2 inch and engages. And so the magnet wheels around the turbine and the magnet wheels around the generator link to each other in a frictionless way so they won't wear out even with millions of turns. And they generate several 16 volts that go back to the capacitors behind the heart, the magnetic amplification generators that are the main power source. They deliver then the energy up to 2 small 12-volt batteries rated at 1,000, 1,050, about 1,000 revolutions per minute. But those two are not engaged. Here it shows an end view of the magnetic generation pairs. And here's one that shows the magnets around that link together. All south facing out of all of them will give the least cogging, the least resistance, and the best linkage. As you press the lever in, it collapses these diamonds underneath the thing. It goes through a slit up to be balanced by these Y columns, and the platform here is raised. And when the platform is raised, they're disengaged. Similarly to the air turbine in front, they have then a 3.5 inch gap, and it will not turn the generators. This allows the combination of these two, the 12-volt system and the 48-volt system here in output, allow you to control the voltage on your meters and therefore the power that goes to the wheels. Because the power that ideally is all level and continuous is not that way. When you leave in the car, the demands are great. They have to overcome the weight of the car and accelerate. It demands more energy. When you're going at a certain speed, it demands very little energy to keep you going unless the wind resistance starts to build up, and then it takes more again. So there's an unevenness to the demands. So there must be some way to the additions, the feeds, inputs, must have some way to vary also. And you must have a 10-20% margin also. In other words, each of these rated at 8 amps will give 16 amps to one wheel at 48 volts, at actually 54, 56 volts, a higher because it gets knocked down as it takes weight, and 2 more to the right wheel, to the left wheel. In order to, you have 2 accelerators in order to remove the need for an axle in the rear. The wheels are then independent, and there's no drivetrain and no transmission. The transmission is totally electronic, and the leads to the transmission, because the transmission are part of the propulsion system, the magnetic drives, but the feed-ins, these 2 levers that I described, their action and their effect, allow you to control the input in different ways, to different levels. All right, so there you've got like, that's fine, you say, as long as you're going to go 30, 40 miles per hour, you've got the air turbine in front, turning 600 revs per minute, you've got the magnetic turbines turning 1,000 revs per minute, you've got enough energy. But what happens when you're finished with your drive? What happens when you're parked? Does all the energy just drain out of your capacitor system? Because most capacitors drain a percent a day, even 1.5% a day from their voltage reading. Now the voltage reading at the end could be higher because after you turned it off you kept the magnetic generators going, and or it may be lower. If it's lower, we have provision for that in 3 other minor organs. First of all, the simplest one is the solar panels on top, right? And the solar panels on top, which we have a lot of experience because we've built dozens of these vehicles for the street, delivers approximately 700 milliamps at 56 volts or 58 volts. And that fits into approximately 24 by 42 inches. And so the roof is actually small.